This is video number 2 in the exponent series about multiplying exponents. So exponents don't just deal with squares and cubes. They deal with any number that can be multiplied by itself a lot of times. For example, if we had 5 times 5 times 5 times 5 times another 5 and yet one more 5, that's a bunch of 5s. And so rather than writing that 5 times 5 over and over that many times, we can write that as 5 being multiplied by itself 1, 2, 3, 4, 5, 6 times, or 5 to the 6th power. So that big number 5 has a name. It's called the base. And that's the factor that's being multiplied over and over by itself. The little number, and we do that in a superscript, so it's a very small number raised up like that, that's called the exponent. And that's how many times the factor is repeated and multiplied by itself. Together we call this a power. So we would call this 5 to the 6th power. One of the things we're interested in is how exponents behave when they are multiplied together. So for example, sometimes we would have something like 3 to the 3rd times 3 to the 2nd times 3 to the 4th. So I actually got 3 exponents, or 3 powers, being multiplied. And the way to most easily understand what the answer for this would be is to expand it out and show what it looks like. So this first 3 to the 3rd would look like 3 times 3 times 3. And sometimes we put parentheses around it just to keep it straight from the other 3's. This next one, 3 to the 2nd, is written as 3 times 3. I'm going to multiply those two quantities together. And then 3 to the 4th would be 4 3's multiplied together, like that. Now what we know about multiplication is that if it's all the numbers are being multiplied, I can not only multiply them in any order I want, but I can group them in any way I want. So I really don't need the parentheses when I'm doing the multiplication. What I need to do to get the answer here is I just need to count the 3's. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 3's. So the answer to this in exponential form would be 3 to the 9th power. Now after you write a few of these out, you might notice that there's a pattern here. When we got 3 to the 9th power from this problem, another way to write that would be 3 to the 3rd power plus 2nd power plus 4th power. You'll notice that 3 plus 2 is 5 plus 4 is 9. So if we keep the base, if all the bases are the same, we just keep the base and we add the exponents when we're multiplying powers. So another example of that rule would be 5 to the 3rd times 5 to the 7th. Now I could write out a bunch of 5's, but knowing that rule I don't really need to now. Now I can just say I know I'm going to keep the base at 5 and I'm going to add the exponents 3 plus 7 and get 10. So 5 to the 3rd times 5 to the 7th is 5 to the 10th power. You could visualize this, or you could even write it out. If you wrote out 5 to the 3rd power, you'd have 3 5's. And if you wrote out 5 to the 7th power, you'd have 7 5's. And if you put them together as one big string of 5's, you'd have 10 5's. So you'd have 5 to the 10th power. So now from those two examples, we can develop a general rule for multiplying exponents. So if I had a base of a to the power of m, and I multiplied that by an exponent with a base of a to the power of n, in other words, if I had the same base and different exponents, the answer will always be the same base a to the power of m plus n, or just adding the bases together. It gets a little bit more complicated if we have numbers attached to the variables. So for example, if I had 4b to the 2nd times 2b to the 4th power, we use the rule pretty much the same way, but what makes it a little bit simpler is if we break these factors into smaller factors. So for example, 4b squared is the same as 4 times b squared. And then I times that by 2b to the 4th, which is 2 times b to the 4th. And then you remember that we can rearrange multiplication any way we want. So what I'm going to do is I'm going to group the 4 and the 2 together and say 4 times 2 here. And I might put parentheses around just to keep it straight, though I don't really need to. And then I'm going to times that by b to the second times b to the fourth. And I'll put parentheses around that just to keep it straight as well. So now I can go 4 times 2 is 8, and b squared times b to the fourth. Using our rule, we keep the base, which is b, and we add the exponents 2 and 4 to get 6. So this answer would be 8b to the 6th power. Another interesting thing about exponents is what happens when we have different bases but the same exponent. And this doesn't happen real often, but it's kind of a neat pattern that emerges. So if you look at what this would look like, 2 to the third would be a 2 times 2 times another 2. And we times that by 3 5s, all multiplied together as well. And so what you notice is you've got 3 of each factor. So what I can do is I can combine a 2 and a 5 to make 10, because I can multiply in any order I want. And then I can combine another 2 and another 5. 2 times 5 is 10. And I got another 2 times 5, which is 10. So what I really have, if I simplify it, is I've got 10 times 10 times 10, or 10 to the third power. So if you notice, the way I got that in a more efficient way, perhaps, is that I look at the bases, if they're different bases, but the same exponent. To get 10 to the third power here, what I did is I multiplied 2 times 5, and got 10, and I kept the base. So another example of that would be something like 7 to the 9th times 3 to the 9th. If I wrote that out, it would look like a bunch of 7s, 9 of them, times a bunch of 3s, 9 of them. And so I could combine 1 7 with 1 3 to make 21. 7 times 3 is 21, and I could do that 9 times. So the answer here would be 21 to the 9th power. So in this application, what we're going to do is we're going to multiply the bases and we're going to keep the exponent. So a general rule for that is if I had a to the m power, or a base to a power, and I multiplied that by a different base to the same power, the result is always going to be a times b, or multiply the bases to the same power that I had, and keeping the power. That concludes this video on multiplying exponents. For multiplying powers of powers, look at video number 3, and for dividing exponents, look at video number 4.